Alright, so our next unit is going to be about talking about systems, and we're going to talk about different methods of actually solving systems. So here's kind of an opening introduction idea for you. There are 21 animals on Farmer Cole's farm, all sheep and chickens. If the animals have a total of 56 legs, how many of each type of animal live on the farm? So for our variable, we'll let sheep be represented by the letter S, chickens be represented by the letter C. So sheep are going to typically have 4 legs, and chickens are typically going to only have 2 legs. So we know that 4 legs with sheep plus 2 legs for chicken has to equal to 56 legs total, because there's 56 legs on the farm. However, we also know that there are 21 animals on Farmer Cole's farm. So in order for us to be able to figure this out, we also know that the sheep legs and the sheep and the chickens have to add up to be 21. So we can actually write those two equations then. So the quantity of animals, sheep plus chickens equals 21, and then talking about the animal legs, 4 sheep plus 2 chicken legs equals 56 legs total. So when we have two equations like that, typically in the past, one of the things that you've basically done has been a guess and check kind of strategy. We could go through kind of similarly, make a picture, start adding up sheep, start adding up chickens, trying to go and see what we can get from here. In our lesson, though, we're going to start talking about what actually happens when we talk about graphing these, and we actually look at them as two linear equations and then going from there. So we'll kind of come back and revisit this idea. On the next page, if you take a look at these two different lines, we can actually see that they both have their own equations. So if we look at line A, it has a y-intercept of 6. Your slope is down 3, right 1, so a slope of -3 and a y-intercept of 6 is going to give us the line -3x plus 6. Line B has a y-intercept of 2, and it looks like a slope of just 1, so y is going to equal x plus 2. So the smiley face, which is right here, you can't really see it too super well. That smiley face that's actually right there is what we're going to call our point of intersection. It also happens to be a point on both lines. So basically, if we were to plug in the x and the y values from that coordinate, we would actually have true statements in both of our equations. So together, these two linear equations are going to form a linear system. And any ordered pair in the system that makes all the equations true is a solution of the linear system. So that point is going to make both of our equations true, so it's actually a solution of our system. So what happens is there's different types of solutions or different types of systems. We can have a system like we just saw before where the lines intersect and there's actually one solution that works for both of them. We could also have a system where we have parallel lines and there actually aren't any solutions there because the lines are never going to intersect each other. The other one that can have the same slope, same y-intercept, if that happens, we actually have exactly the same line. So really there are infinitely many solutions because all of the solutions are going to be there. So that's another thing that can also happen here. So if you flip over, we're going to talk about the graphing method then. So if we look, we can go through and we have a couple examples here. So in these systems, we're going to actually solve them by graphing. So what we'll do is we're going to actually draw both of these lines on our graph, and then we're going to see where they intersect each other. So 2x minus 6, 1, 2, 3, 4, 5, 6. Slope of 2, rise over run, rise over run. And I'm going to actually go through and use a ruler here. Typically we weren't doing that before, but because we're actually looking for this point of intersection, it's going to be important that our line is actually relatively straight so that we can see where the graphs cross over. The other one is 1/2 x plus 6. 1, 2, 3, 4, 5, 6. And 1/2, so up 1 over 2, up 1 over 2. Remember, slope is rise over run. And I'm going to go ahead and plot these two. Just by lining up that ruler, you probably realized that it looks like they're going to cross over right up top here. So that point is going to be 1, 2, 3, 4, 5, 6, 7, oops, 1, 2, 3, 4, 5, 6, 7, 8, 9, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Actually, looks like we should actually be at 8, 10, sorry. So at the point 8, 10, they're actually going to cross over there. If we take a look at number 4, 1/2 x plus 3, 1, 2, 3, up 1, over 2, up 1, over 2, and 3x minus 7, 1, 2, 3, 4, 5, 6, 7. 3 means go up 3, 1, 2, 3, right 1, 1, 2, 3, right 1. So we're going to actually do these two lines. And our intersection is going to happen over here. 1, 2, 3, 4. 1, 2, 3, 4, 5. So at the point 4, 5. So that's how we actually go through and check. If you want to graph 5 and 6, in number 5 you should intersect at the point 2, 1. And number 6 you should intersect at the point 2, 0.